This is a pulley. This is the component given by the customer. This component, gear grinding to be done. For this component, this is the portion, clamping diameter, to be clamped. We have designed a mandrel, a hydraulic mandrel. This mandrel, it is a chuck, we call it a chuck type of. So when it clamps in the ID, it's a chuck, clamps in the OD, it's a mandrel. So this inner lining sleeve, it is the clamping sleeve. We call it as clamping sleeve, which is highly chrome plated and fully finished mandrel. This is. And this is a refill. This is the refill portion. You can see a small M6 Allen cap screw, the refill portion, and this is actuator portion, and the centers are well ground and protected centers. You can see a good finished mandrel. And now that is free, the mandrel and the component are free. You now actuate the mandrel. Actuate the mandrel while they, before setting into the gear grinding machine. Keep the component and keep the mandrel. Just turn one clockwise movement of the actuator port. Clamped. Now the pinion component is well clamped and it is ready for gear grinding. You can do the gear grinding. And you finish the job. Dismantle. It's ready for the next component. So it's a few seconds of job. There's no need for setting and truing and so many waste of your cycle time. Your time is precious, so you have to save a lot of time. And it should be foolproof method, and it should be able to give the accuracy, and the end result should be repeatable. Repeatability should be ensured. That is, your process must be a capable process to produce repeatedly number of components over a period of several shifts. This is how the clamping and the declamping. This is so simple, the hydraulic mandrel works. This is one such example. This is another gear grinding mandrel, which is MT5, which can be directly fit into a spindle, so that whatever the accuracy of the machine, the mandrel reveals the same accuracy. Then only thing is, this is to be transferred to the component. Holding the component here, you do whatever the operations, the machine and the mandrel and the component are set in line. The axis, whatever the axis error of the machine, the same thing is reflecting. There is no extra error due to additional clamping mechanism like a chuck or like any other device. So this is a chuck hydraulic system where it is, the particular case is for a ball, for several ball races. So the ball races, the IDOD concentricity is very close tolerance to be maintained within 10 microns, and the sizes should be repeatable. The repeatability should be ensured. So multiple components can be ground in one setting. put about 5 components and do the clamping, and all the 5 components are held, and you do the ID grinding. Now the ID is centralized. Now with reference to the ID, put it in a taper mandrel. Again one more expanding mandrel with reference to the ID, you clean finally the body. So the ID and body will be in all the components, and whatever the dimension of the first component should be the dimension of the nth component. The consistency is maintained. The working principle is, for example, let us take 3 components, 3 ball races. Here the ball races are OD centralized ground. So the ball races, because of its tendency, before it's said to be finished ground, the ID-OD concept is that it should be maintained within 10 micron at the end. So what you do first thing is your mandrel, your OD grinding mandrel. This is the body grinding mandrel. This mandrel, when you put the component, have got different IDs. See, ID due to the tolerance in the bore, 25 microns. See, one component at the minimum, one component at the maximum, one component in the mean. So when you put it inside a hydraulic mandrel, when you actuate it, the mandrel actually takes the shape of this. And finally it centralizes all the components. According to the bore, the mandrel expands and then contracts and expands, and it aligns the center line of all the components in one single center line. And now you are able to whatever do the OD grinding, it is true to the ID. The component is aligned with reference to its variations of the bore, and it is center line is aligned. Now what you can do, you can put it in the chuck, all these 3 components in a hydraulic chuck, same way, whatever I have shown. This chuck, put the components and clamp it. Now the OD is centralized with reference to OD. Final finish the ID OD is pakka. It is done well. The job is, whatever the result is achieved. So this is what we call it as the gel. This is the gel which we use for transferring the pressure, the hydraulic mandrel. Can you able to see, all of you? So you can use it for the rotors, different varieties of rotors, and there are plenty of all the varieties of gears, pistons. Can use it for the pistons, valve guides, and much more applications. This wide and thousands of components can be made into this hydraulic expansion mandrel and chuck technology, and you can save a lot of time, you can save a lot of money, and component will be meeting the process capability limit specified by the customer. And this is a continuous improvement. It takes us to the next level. Among a large population of vendors, will be rated at a better level and will improve the business.